Hi, everybody, and thanks so much for having me to this virtual talk. Today I'm just going to talk a bit about the work that I've been doing on realism with virtual characters and investigating that in different ways. My interest in photorealism are basically generating virtual characters that appear as though they're a photo, that as a render, it looks like a photo of a real person. My interest in this started about 10 years ago. And back then, the main striving for photorealism was in offline rendering, so in things like movies and visual effects. So striving to create characters that look almost like real humans in those. But over the years, and in the last couple of years, this type of photorealism is actually now possible in real time. So these two examples, one are from demos at GDC in the last couple of years. So there's Trilateral Siren demo and then the DigiDoug demo on the bottom there. So as you can see, the realism of the graphics and of the humans is really, really high. So we really are getting close to creating photorealism, and the fact that this is in real time is really exciting. So whereas the work that I was originally kind of looking at the effect of realism on our perception, or 10 years ago was more about movies. Now there's so many other questions related to realism. So when you're interacting with the virtual character in virtual reality, for example, or if you're allowing a virtual character to represent you in virtual reality or over a video conference, how does that affect our perception of interacting with these humans? And is it actually a positive choice to go for this photorealism? Do we really need that? Or should we be looking to more stylized or less realistic representations? So I'm going to just kind of talk a bit about the different work that we've been doing on that. One area that is related to this would be, I guess, what we call the uncanny valley, which is a theory that was proposed back in the 70s related to robotics. But it's been used quite a lot as a catchphrase for virtual characters that appear kind of eerie and give you a kind of a freaky sensation. So it's the idea that the more human-like a robot or a virtual character becomes, first of all, you feel quite happy with it. It gives you a positive response until it gets to a point at which it causes a negative response, because it's kind of tricking your brain into thinking, well, this looks like a real person, but it's not. I don't want to engage with that at all. So that's this drop in realism there is called the uncanny valley. So a lot of literature around realism has mentioned the idea of the uncanny valley. So let's avoid it. So I guess a lot of the more cartoony animation studios have been avoiding realism for stylization reasons, or is it perhaps to make the characters more appealing? So in general, you could say, why not just always use kind of more stylized and cute characters rather than trying to aim for photorealism, because this will give you an appealing result. But then you have to think as well about the appropriateness of the character in the situation. So this example I have here is it was a Facebook demo that it didn't go quite so well, because they were demoing the new Facebook Spaces, which is where it's a kind of a digital hangout spot. But they did this with cartoony virtual characters with the backdrop of the Hurricane Maria in Puerto Rico. And there was a kind of a sense of inappropriateness for the jovial and cartoony and happy looking characters with this kind of tragic backdrop. So I guess the point here is that there's no one answer. Yeah, you should definitely use a realistic, you should definitely use a cartoon, and then it obviously depends on the task as well. So this is what we've set out to investigate over the years. So in this talk, I'm going to just talk a little bit. Darren wanted me to mention a bit about our technical pipeline. So, I mean, one of the things about trying to do experiments on photorealism is that you need to try to replicate these massive budget movie and game studios. So we've had to develop a technical pipeline to try to emulate the results that they get there. And then I'll talk about a range of different perceptual experiments. So the ones that we did on appearance in general, then where we looked at behavior, and then more recently we've investigated photorealism in virtual reality, and then we'll just conclude. So first of all, the technical pipeline. So like I said, trying to replicate these types of stimuli is very tricky because, like I said, they're very expensive and difficult to do. So I guess this is just an overview of the technical pipeline for facial animation in particular. So you've got your model creation side, which actually is one of the most time-consuming and expensive parts. So in this, we usually collaborate with people like Trilateral, so digital double companies to work on characters there. So the model creation side is usually based on very high detail scans of people and a massive pipeline around creating really nice micro expressions and everything from that. And then obviously motion capture, which you'll be very aware of at the camera center, where we're using optical motion capture, and we have a number of different ways for doing facial capture. So with Technoprops headset or with the iPhone X if it's more in real time. And these then are fed into the retargeting pipeline, retargeting, which basically means applying that motion capture. So you've captured the motion, you've captured your character. Now you need the character to move as the motion capture actor moved. So we've looked at different commercial and also custom solutions for doing this using machine learning or other products. And then finally, the real-time display. So depending whether we want to render these out as movies or if we want to actually interact in real time, testing out a game or testing out a virtual reality experience with them, there may be an element of optimization to be done there. So we've done some work on looking at optimization for real-time display, and then again we use a lot of the commercial solutions as well, like Unreal Engine and Unity, and the Oculus Vive and the Oculus and the Vive to display. So that's kind of our technical pipeline. At the moment, it's constantly changing, constantly being updated, trying to keep up with the latest advancements. I'll show just one example of a recent character model that we worked on. So this was a character scan done by the company ESCO, where they did photogrammetry scanning on this actress and got her scans. These are only a subset of all the micro expressions and big and small expressions that she did. This about 200 or 300 of these scans in total. So that was behind her rig. And it was done at a light stage, so it allows the character to be relit in any environment then in 3D. Here are some recent tests that we've been doing on this character in Unreal Engine. I don't know how high res you can see it across there, but on the left there, we just show kind of a typical rasterizer example. And you can see that the skin there looks a bit chalky, the eye looks a bit glossy or a bit kind of milky. It doesn't look particularly realistic. And on the right here we have, we're using the latest real-time ray tracing in Unreal Engine, and we can produce nice realistic shadows. As you can see the eyelashes there giving nice shadows onto the eyes, subsurface scattering, all the latest kind of effects for the eye rendering as well, and all the detail of the sclera and lacrima and everything. These again both in real time. We're just playing around with all the latest in Unreal Engine, including things like dynamic materials, which we can see. If I don't know if my video is working here, but you can, if it is working, you'll see a little bit of the dynamic material there showing skin sliding, which gives a much more natural appearance of the wrinkles on the forehead than you would get if you didn't have that. So these are all the kind of things we're playing around with at the moment in our technical pipeline. So now to the approach that we overall generally take with regard to investigating realism. So I suppose it all starts with the algorithms that generate the high resolution graphics, whether it's the algorithms for the blend shapes or for the lighting equation or whatever it is that these feed into the graphics. Then we think about visual perception and how we perceive the resulting graphics. So, we might run some experiments then. Do these look, asking people, for example, how realistic is this? And this can help us then to feed back into the graphics to decide what parameters to use, or to generate perceptual metrics, which allow us then to, for example, alter the algorithms for effects that are potentially computationally expensive, but not visually important. So this is the kind of general overview of the pipeline that we're using at the moment. So a lot of perception experiments, a lot of getting participants into the lab and doing a lot of investigations, which of course is kind of difficult at the moment, but we've been doing our best with online experiments. So here are some of the, just an overview of the types of experiments that we conduct. So we use things like direct or conscious measures. So things like subjective responses like Likert scale. So we might show an image of a realistic virtual character and get the participant to rate it from highly realistic all the way down to extremely stylized, and pick their point in between. And then we also use standardized questionnaires. So in the example here on the right, I'm just showing the 10 item personality inventory, the TP one. So this is a real personality test for real people, but we can adapt that then for virtual characters to determine if there are differences in personality perception, for example. So they're the direct and conscious kind of measures, which in some ways are very standard, very typical. Then you have the indirect measures, which I find very interesting to try to get a subconscious measurement. So one of the things about the uncanny valley and the idea of virtual characters creating a negative response is that it's often mentioned it's very hard to directly measure that. So we've been very interested in looking at different indirect measures of how affinity towards virtual characters. So things like behavior, we could test behavior in a game. So does it affect your decision making? So we've looked at things like moral dilemmas in a game, and if the character appears realistic or appears cartoony, does that affect how you make your decisions? And then obviously there's the psychophysical response. So you can have things like MRI. Now we haven't done anything with MRI, but skin conductance and other kind of measures of heart rate can be very useful as indirect measures of how the actor is responding. And then we could use things like social cognition bias and implicit testing. So these are the general measures. So I'm going to talk first of all a little bit about the direct measures, and then we'll talk more about the behavioral experiments that we've done. So the first set of experiments then were all run with direct measures, so just Likert scales. And here we were looking at investigating basically all of these parameters that might, so as you saw in the technical pipeline, there's a lot involved in creating a virtual character. So from the model creation to the rendering to the animation, there's so many different components that in order to determine which one of these is most important, you have to start to split it out into the different components. So in these next couple of experiments that I'm going to show, we've split them out into different components to investigate what are the most important ones for appeal. So it's mainly about appeal. We want to create characters that are appealing to the audience. So the first experiment back in 2012 at SIGGRAPH was where we just investigated render style. So here we allowed our animators, our artists, to change around the lighting, the textures, the materials, to try to replicate some typical styles seen in the industry, like a Pixar style, an ink and paint style, and a realistic style. We have a bunch more than this. This is just a subset of them. So in that sense, we didn't control for things like lighting or ensuring that it was the same type of rendering pipeline. It was just the artist was allowed to do all that to try to achieve the style. So that was the first experiment. I'm just going to go through what we did, the different parameters, and then I'll talk about the results that we got. So that was render style in general. And then in 2015, in SIGGRAPH Asia, we presented a further investigated where we separated shape and material. So we wanted to separate these two parameters because in 2012, we used all of a realistic shape, and we created our cartoon shape just by changing material. We were interested to see then what are the effects of material and shape separately. So again, we got an artist to create a bunch of different styles, which we replicated from different styles in the industry. And at the top there, we had a photogrammetry scan of a real person. So these were all generated. And then we generated stimuli all along the continuum. So the material of this character was copied across all of the different shapes, and you can see that we did that all the way along. So so we're kind of trying to separate the two points. So you see here the realistic materials being applied to all the different shapes. So you can see there that it starts to look a bit eerie when you apply realistic texture on a cartoony shape. So that was the other experiment. We looked at shape and material. Again, I'll talk about the results after. And then finally, so one of the things about these was that lighting wasn't kept constant. Well, it was in 2015, but we were very interested to determine then what the effect of the lighting itself was. So this experiment will be presenting at SIGGRAPH next week in the cinematography session. I don't know if it's next week or the week after, but this was a large-scale experiment where we separated the key light and the fill light brightness on a character's face. So we created, this is just a very small subset of the different lighting parameters we created, but we looked at the effects of brightness independently of shadow, and then shadow independent of brightness, and created a range of different stimuli to investigate what effects these might have. So we were interested in the effect on appeal, so how lighting affects appeal of virtual characters, but also in this case we were also interested in emotional intensity. So if the lighting had an effect on the intensity of the expression or the recognizability of the expression. So for example, would a dark shadow inhibit your recognition of the expression? Okay, so those are the three kind of big studies that we did on the different parameters, and just the key findings on photorealism. We obviously investigated a number of other things, but in terms of photorealism, our key findings were, first of all, we never found a particularly negative effect of realism. It was found appealing quite a lot of the time. It was more the characters that were hard to characterize that were considered eerie. So any of the characters that maybe had a cartoony appearance, but more realistic material, so that there wasn't any, you know, it was more difficult to categorize them. So all of the characters that had a congruent material and shape, for example, were considered appealing. But once they differed from that and were in the kind of in the middle of the region, these were the ones that were considered eerie more than the realistic. We found that shape was the main predictor of realism. So this is kind of interesting from the point of view of some of our early experiments where we were changing, and we do it in some of our later experiments as well, where we change just the material to create like different versions of the character. So we want to create a cartoony version and a realistic version, but actually it's the material, it's the shape that predicts the realism. So as long as you've got a realistic shape, so if you've got that photogrammetry shape, it doesn't really matter as much how much, what type of material you apply to it. that character is still considered more realistic than the next shape down. So when the character starts to have that like small nose and the big eyes, for example. So shape is the main predictor then of realism. Material then we found was the main predictor of appeal. So this kind of replicates the idea of, you know, your Zoom calls and everything, or your new portrait photographs, where the face, the texture of the face is kind of smoothed out to make it more appealing. So this was replicated here. We found that material was the main predictor of appeal. So once you had a smooth looking kind of appearance of the material, that predicted how appealing it was. For our brightness experiments with the lighting, we found over all of the experiments we conducted, and we conducted a lot of experiments, we found that brightness of the light source improves appeal. So once you have a nice bright light source, your character starts to look more appealing. And this, I suppose this is kind of replicated in a lot of the preschool cartoons, where they take the approach of all the time the light is bright in those CGI kind of cartoons. So but we found that to be the case even for realistic characters, that if you brighten up the character, it looks more appealing. So sorry, brighten up the light source on shining on the character. We found then that for the shadows then, so first of all, the very dark shadows can actually inhibit your perception of emotion. They can make it a little bit less easy to recognize. But we found that dark shadows did have an effect on the toon characters. So if you say, for example, you have a toon character on a cartoon, and you decide you want to have a dark shadow on the character, that will reduce the appeal of that toon character. However, the dark shadows had no effect on the appeal of realistic characters. So it didn't matter how dark you shone, or you had a shadow on the face of the realistic characters, it had no effect on their appeal. So these are kind of interesting results for when you're trying to aim towards creating realistic or appealing characters in general. So these are generally our key findings there. Okay, so but a lot of these experiments were conducted on, you know, either static stimuli or moving, but we weren't looking so much at behavior. So the next set of experiments that I'm going to tell you about here, just keeping an eye on the time. Yeah, we're okay. Are our behavior experiments. So again, we're looking now at so in the first set, the appearance. We're looking for the different parameters that we can change. So the texture, the lighting, you know, the realism, to make the character looks appealing to a user. But now we're interested in, if you use a realistic or a cartoony character, does that actually affect the behavior of the user? So will the behavior of the user change to make you, you know, to show that you actually have an affinity towards that character? So these are just a subset of the behavioral experiments we've been playing around with. This is more a newer one, so I thought this would be kind of an interesting one to show. So this was where we did a multimodal experiment, and we wanted to know if, so first of all, we decided to create a game scenario. So we wanted our users to interact in a game. And we wanted to see if we had a realistic or a cartoony character giving the instructions in the game, if this would affect how the player played the game. And we also tested the different modalities of voice and face. So we recorded what's called a smiling voice, which you may not have heard about before, but there is for example, if you ring somebody, you are able to tell if they're smiling through their voice. It is perceptible, so audible, the smiling voice. So we wanted to see if a smiling face and smiling voice, for example, would give a more positive result. And we tested all different combinations because we were interested in that. So I'm going to just show some of the stimuli examples. Oh, so first of all, I'll just tell you what the experiment was about. So it was The experiment was you were told that you were landed on the moon and that you had to pick 10 different items to take on an expedition across the moon back to your ship. So the participant first of all rated the ordering of the items. Then the avatar would tell them, no, you should have done this, you should have done that, and then they re-rated their items. I'll show the example now in a second, but here are just some of the stimuli examples. First of all, of the realistic.
I think the milk would be a good source of calories and energy.
So that's the smiling condition.
I don't think we would need the milk. It would be too much effort to carry it for too little energy.
The neutral condition.
I think the book on edible animals would be helpful to find food.
Cartoon.
The flashlight might be useful, but only during the night.
And this one had a neutral.
I don't think the book on edible animals would help us, since hunting would consume too much energy.
That example had a smiling voice but a neutral face. Now, I know across teams that there can be a bit of a delay in the lip sync, so apologies for that if that's the case. So these were our different character examples. So in an experiment, you just saw one of these conditions.
I think.
So let's have a look at this. Is the task itself. So this is where first, 6 items. First of all, the participant rated the items like that. And then once they had them rated, they submitted their answer. And then the avatar assistant made the suggestions to them.
I don't think we would need the milk. It would be too much effort to carry it for too little energy. The rope could be handy, but carrying it would slow us down. The receiver transmitter might be useful, but only if someone happens to be near us. I think we would need the heater so as not to freeze when we rest. I think the parachute fabric could protect us from the sun's rays. I think the raft would be useless, since there are no watercourses on the moon.
Okay, so then once the avatar had made the suggestions, we allowed the participant then to make their suggestions again. And we had all different versions of the avatar where they were positive or negative versions, trying to get the participant to rate something higher or rate something lower. And we did lots of analysis on that to determine the if it was statistically significant, whether or not the avatar was able to persuade, basically. So we're looking at a kind of persuasion or trust. So whether or not the user trusts that avatar to make the decisions or not. And we also included a large questionnaire after this experiment to determine their direct responses. Did they find it appealing? Did they find the character trustworthy? All that kind of stuff. So the behavioral result was, were they more inclined to accept the suggestions? So this experiment was actually run in our local science gallery, which is a science museum that's affiliated with our university, and they have really nice exhibitions where the public get involved in the research, and there's kind of artistic and also scientific exhibitions together, and we put this experiment in as part of one of the exhibitions, and we had over 1,000 participants take part in the experiment. So it was very much a big sample of participants taking part there. So just the key findings then from that, and we have a number of actually, sorry, this experiment was conducted in lab, but we have some other versions of it where we did it in the science gallery. We found that the cartoon agent, there was more positive traits associated with, so it was considered overall more appealing, more attractive, less eerie. Similarly, but for things like trustworthiness, intelligence, and knowledgeability, these were all rated the same. So perhaps it was more to do with the voice that gave us the results for those. However, when it came to changing their decisions, so the behavioral change, we did find a behavioral change which indicated that participants were more inclined to accept suggestions from the cartoon-like agent. So once the cartoon-like agent was telling them to change their to change. They did. In general, the avatar was quite persuasive, so participants were likely to make changes due to the suggestions of the avatar. On the audio-visual mismatch, we found a bunch of different results on that, but one of the interesting ones was that if there was a mismatch in the audio and visual, so for example, if the voice was smiling and the face was neutral, this was interpreted as kind of sarcasm, that mismatch wasn't didn't appear well. Okay, so that was that behavioral experiment. Another one that we looked at was looking at personality. So I mentioned before that we use kind of standardized questionnaires for personality, so things like the TP scale. So this was an example where we did motion cap. Yeah, I suppose one of the issues with a lot of these experiments is trying to get realistic scenarios. So we wanted to make sure that to try to get a scenario where an avatar was going to be presenting a different personality. And it's very difficult to kind of go and find lots of motion capture actors to come in and test their actual personality. So what we did in this case was we investigated all of the psychology research on personality, and we looked for all. So these are on the top right there, the kind of different traits that are in the ocean personality model, and we looked for indicators of these traits. We recorded them based on previous literature, and then we developed scenarios that would bring out some of these personalities. I'll just show you. So we had just two render styles in this. We did kind of an ill-looking character, purposely meant to be unappealing, and a toon. And the character just spoke for about a minute, I think, and was supposed to portray a personality. I'll just show you.
Look, I can't believe that I give you this. I give you the car for one day, and look, it's destroyed. It's ruined, and I have the biggest meeting of my life tomorrow, and I can't get to it because the car has been destroyed. The boss is gonna think that I crashed the car because I'm not even, it's meant to be a company car. I'm not meant to give it to people. And now I have to come up with some reason why I can't make it there because you crashed my car.
So this is an example of a disagreeable personality. I'll just show you a little bit of the other character.
Oh my God, I can't believe it. That's exactly what I was looking for. How did you guys know? I've been trying to find this TV so long.
So that was more of an agreeable personality. Whoops. As you see, this was kind of an older pipeline of ours, so the facial animation wasn't very good back then. But the idea then was to see if, so we applied these different personalities to both characters to determine if the render style alone, so if could affect the perceived personality, or is the audio and the performance the main indicator of the personality. So our results in this experiment was that, so we used the standardized questionnaire for personality. We found that personality was recognized, so this kind of validated our approach. So the different personalities that we were going for were recognized, so that was good, above chance. And then the render style was shown to also affect the perceived personality. So this we found very, very interesting. So by presenting the exact same personality and scenario, just by applying a different style of rendering was able to change your perception of that personality. So this was we found this a very interesting result, especially for the idea of the uncanny valley, because there's been a lot of theories around, that it might not be the fact that people are using realistic render styles. It might just be the particular movie wasn't very good, for example. So this was a step towards acknowledging here that the render style can actually have an effect directly. So in this case, the ill or kind of unattractive character was rated as less agreeable throughout all the personalities than the toon. So just having that negative render style affected the perceived personality. Okay, so that was that study, and then we did a similar study here on personality again, where we looked at all the psychology research on the different personality types and how these could be portrayed by just head nods and eye blinks. So the idea of this was for example, a chatbot avatar assistant. If you want to portray a different personality, that you can change the way the character's personality is perceived by just the way the character listens to you. So again, we had actors then incorporate the results from the psychology that we built. So here's an example, and we applied them to a toon and a realistic character. So here's an example of agreeable. So we had things like, the number of blinks per second and the number of head nods and things like that should be associated with an agreeable character. Again, it would be great to get these to get actual people with these actual personality traits in, but again, just time and the ability to do the large scale motion capture like that wasn't possible. But we validated this approach since the personalities that we wanted to elicit were recognized based on the head nods and eye blinks alone. So that was good. Again, this was a TP questionnaire that was a typical personality questionnaire. However, in this case, we found that the render style had absolutely no effect on the personality. So in the case of a listener behavior, so the first experiment was more of a talker behavior. This is listener. The render style had no effect. So the motion itself was quite strong in this case, and it didn't matter how it was rendered. So we thought that maybe the toon character would look more appealing in general, but we did not find that to be the case. So it's possible that the previous study was because it was the character was talking, or possibly because the character was purposely unappealing in appearance as opposed to realistic. So that was the result of that experiment. Okay, so in general with behavior, we've had kind of mixed results with terms of realism. Generally, quite positive effects of the cartoon, especially in behavioral determination, so personality or change in the behavior of the user. So now, because of the fact that obviously virtual reality is a very hot topic these days, and also the fact that we can do a bit more in terms of interaction with the characters. This naturally moved us into looking into virtual reality and looking at interactions in 3D space with these characters, because all of the previous behavioral experiments we had done where they were just videos or just a game that you played, whereas here we can actually go into the same room as these characters and see if we can affect behavior. Again, in virtual reality, it's easier as well to detect behaviors, because you can track the person in real time and track their movements and see how they're reacting to the character. So obviously there's been a lot of research in the past on interactive virtual environments. So investigating people's responses to expressive virtual characters. So there are some examples. Things like proximity is a very commonly used measure in the literature, and this is about personal space, and we all know about this at the moment with social distancing. But proximity is about generally how a person spaces themselves between themselves and another person. So, for example, if you were a business associate, you might stand a bit further away than if you were a friend. So this idea of proximity is this closeness in space, and it's something that's very easy to measure in virtual reality, because you can measure all of those things. Mimicry is another one where you imitate the character's gestures. Another one is the length of time in VR. For example, if you like the character, if you like interacting, you'll spend longer in there. Okay, so I'm going to outline, we have 4 different experiments that we conducted in virtual reality. I don't want to go into details of all of them, so I'm just going to generally tell you the 4 different experiments and then the general procedure, and then I'll summarize all the results that we got from those. So this idea of proximity we found very interesting and we thought this could be our new measure of the uncanny valley or affinity or appeal of a virtual character, because like that, we know that if you like somebody, or if they're a friend of yours, or if you have a positive reaction to them, you will stand closer to them than if you feel more negatively or there's a more of a distance. So we felt that proximity could be very much used to test this, and we tested this out at length. So our first experiment back in 2017 is where so this was using an Oculus Rift. It was a kind of a typical setup. We had a very simple environment, as you can see there. So just walls and a ground. And we had the same virtual character again presented in different render styles, so cartoony and realistic being in there as well. So we replicated one of the literature from Bailenson proximity experiments, where you write a word behind the character, and the person has to interact with the character, then walk around and look at the front and say what that word was. So the idea was you get closer to the word if the proximity was the measure of your proximity. So in some sense, that wasn't the perfect proximity measure, we didn't think, and we didn't get any results from proximity there. But we did get some other interesting results in that experiment that I'll tell you about. We moved on then to do a second experiment where we looked at proximity a little bit differently. And we ran this again in the Science Gallery, and we had about over 1,160 participants or something like that did this. And again, we looked at personality in this case. So we went back to the scenarios from the previous experiment and put these in virtual reality. And then we wanted to test proximity with regard to render style and personality and those different combinations. So those were the first 2 experiments. But again, there was a number of issues with these experiments. For example, the character never really acknowledged your presence. So the character was just kind of talking and looking ahead. So the social presence was low. So you didn't really feel like you were in the same room as the character in these 2 experiments. So we tried to improve that then in our next 2 experiments. So the third one was where we aimed for higher realism with a character from Unreal Engine Paragon, and we also got a really realistic virtual environment from Unreal as well, because the previous experiment had been conducted in this very simple room, but we felt that maybe having the realism of the room match the realism of the character could give us some interesting results. So we ran this in lab with a full embodiment experiment, where the person interacting was actually full body motion captured in Vicon while they were interacting with the character. So then we could measure every single movement that they had, and also how close they got to the character in a much more natural way, because it wasn't using a game controller to walk up to the character. You were actually physically walking towards that character. So I guess this was the best possible setup that we had for measuring proximity. We also measured things like empathy. So we created a kind of an empathetic scenario where the avatar was sad, and we wanted to measure if the realism of the character affected how empathetic you were towards them, and also if it affected your proximity. And the fourth experiment then was, we ran this a kind of a pared down version of this experiment again in the Science Gallery, and over 600 people took part in that. But in that case, it was a control. So we did proximity in a different way that time. We actually just placed, because we couldn't do full body motion capture on 600 participants, we just placed the embodied character very close to the talking character, and we tried to determine then if that was an uncomfortable space for them. Okay, so I'll show you, I'll just keep an eye on the time there. I think we're nearly done, so I'm just going to quickly run through this. So the idea of all of those 4 experiments was very similar. So you had your participants set up in VR, sometimes with motion capture, sometimes with not. We nearly always had a training room where the participants, so this black character here was the character that was being full body motion captured in Vicon. It's a Vicon character, you might recognize it. So we did, in the training room, we always had the same VR environment, but with a pillar or some object instead of the character. So in that experiment, we asked the participant to walk around the pillar or walk around the character. We just said, get the controller that's sitting on the chair over there. And it just naturally they walked around. You know, they could have easily walked through that pillar, but they naturally walked around it. So that was the training room. And then the experiment room showed the character expressing an emotion.
Watering
if you can see this.
Yeah, I just came from the hospital visiting her, and she's in so much pain. It's so terrible to see her like that. You know, I was driving that night.
Okay, so that example was the realistic character. Again, the facial animation not perfect there, but with an empathetic scenario, and also in this case we had a behavioral reaction. So the character's eye gaze was looking at the participants. So this massively increased the social presence. So you really did feel like you were in the room with that character. And then after that, we would do a measurement of proximity. So we tried multiple different versions. This case was the person had to walk around the character to pick up a controller behind them. So we were able to measure all the full body mocap of that. And just quickly, we ran a questionnaire then, and most of the time we tried to make sure that the questionnaire was incorporated in the environment. So we didn't want the person to come out of the virtual reality experience before they did gave all their reactions. So in this case, we just had it on the television that was in the room to try to make sure that they were still immersed. So we tested things like place illusion, if they had the sensation of being in that living room. A social presence, which means that they felt that there was another human being in the room with them, embodiment, and concern. Okay, so over all the experiments, the 4 experiments that we conducted, I've tried to pull together the kind of results that we got. So the first hypothesis was that the realistic style would increase place illusion and social presence, and we did find this to be the case most of the time. For the first 2 experiments, we had low social presence in general. But the improved behavior, particularly when you embodied the person interacting, we did find this. So realism was positive in this sense, that it increased the sense that people felt they were in the room. It also increased the social presence. So this is I think this is a good result for virtual reality and for moving towards realism. We felt that the realism would increase empathetic response from participants. So this was related to the fact that you're seeing a more realistic character. Does this make you feel more empathetic towards them? In general, we found this not to be hugely so. Sorry, it was kind of yes and no was the answer. So in experiment 2, there was higher concern, but it was more linked to the personality than to the render style. But we did find one incident where the neurotic personality, there was higher concern for that character when they were rendered realistically. And similarly in experiment 4, we found in certain circumstances that higher concern happened for the sad photorealistic character. So this is all aiming towards the fact that, yeah, it's possible that realism is a very good choice for virtual reality, but we have to be careful because especially if you're putting people in virtual reality scenes that are highly realistic and maybe emotional, you have to be careful that this might increase the emotional response from the user. Proximity, unfortunately, has never worked out for us at all in any of the experiments that we tried, all 4 of them, with all the different types of proximity. We did not find proximity to be, so here's just an example of the trajectories on the left of the realistic and on the right the simple characters. So we just found no effective proximity for most of our experiments. according to realism, but proximity did have an effect on other things. So, for example, people felt more comfortable and got closer to a character that was expressing a sad emotion. There was an effect of gender, where males in general felt more comfortable with the scenarios, male participants. And we also found that proximity was affected by your interest in the character. So if you're, in particular, we had a zombie character at one point that people actually ended up getting closer to, and we believe it was just to view the details of the character rather than feeling particularly comfortable. So I would conclude from that proximity wasn't a very good route in order to determine if a character, if you had affinity towards, or this uncanny valley effect. Okay, I'm conscious of the time now, so I'll just conclude up the fact that, okay, so we've conducted a number of these experiments. I believe that the future is going to be full of lots and lots of interactions with virtual characters through social media, virtual reality, virtual assistants, medical training. They're going to be everywhere in the next couple of years. So I think it's very important to try to understand what are the different parameters that are going to affect how we interact with them, things like lighting, render style, material, and how emotion and personality are seen on these different characters. So it's also important to understand how they affect our behavior. So will they make a difference to our empathy levels, our social distance, all of those, trust, all of those different things. So I think there's still a lot of work to be done on investigating photorealism in virtual humans. Our next work, we're looking at conversational agents and trying to replicate realistic style with them. And we've lots of tasks and scenarios where that could be interesting to investigate realism. And similarly for live motion capture, we're aiming to try out the sense of embodiment in more realistic bodies, etc. Okay, so just quickly before I finish up, I just say thank you to all my students and collaborators. And all the sponsors of this research. And thanks so much, everybody, for listening. I hope I haven't gone on too long. Thanks. Let me just unshare that there. Yeah.
Okay, thanks, Rachel.
Hi.
Hi.
You got me.
Very
Yeah.
much. Thanks a lot.
Thanks for listening.
So before I kind of so I've got some questions I was going to ask, which would be quite interesting to hear your answers on. But I think before that, has anyone else got any questions they want to ask Mitchell? If so, put your hand up on the. So Emily's got a question.
Hi, Rachel.
Hi, how are you?
Hi, I'm good, thank you. Thank you so much for the talk. It's a very interesting subject. So I was wondering, when you sort of analyze how people, for example, if an avatar is kind or not, I was sort of thinking that I guess because of, for example, upbringing and so on, there might be different groups of people experiencing completely different. So sort of thinking that one group might find a smiley person trustworthy, whereas another group might not find that at all. So do you sort of take that into account to, in some sense, I guess, keep the diversity?
Yeah, we try to. I mean, I suppose it depends on the experiment that we're doing. Like the ones that we did in the science gallery, so where we had 1,000 participants, so that we definitely tried to get all the information about the demographics of the participants. And a lot of the time as well, we will do personality experiment or personality questionnaires, or maybe a reduced set of them to avoid it being too long on the participants themselves as well. So we tried to match up then if the personality of the participant affected their judgments, or if the gender of the participant affected their judgments, for example, ethnicity, you know. So we do, yeah, we try to get as much information, especially when you're talking about more experiments that involved social interactions with characters, because some of the more lower level experiments were like same or different, or, you know, is this realistic or not? We don't worry so much about it there. But definitely, yeah, in the case of social interaction, we do try to measure. Now, I can't say that we've any particularly huge conclusions from that. I think we generally get some small effects. And of course, we report them in the work, but we haven't seen anything majorly affected by that from the experiments that we've done. Gender had some effects, all right, but yeah, kind of in the expected way.
Yeah.
Yeah.
Okay, nice. Thank you.
But again, another problem with that is, again, when you test personality, so even in an experiment that's done in the public with 1,000 participants, you might not get good amount of the different personalities, you know. So you might have a huge amount of, you know, agreeable people, but not so many neurotic or you know, some of the other personalities that you might be interested to test the effect of. So again, yeah, sample size is always kind of important for that. And again, getting diversity in ethnicity, for example, can be difficult in a lab in Dublin, for example. You know, but we do try. So, you know, some of the experiments we ran using crowdsourcing, like Prolific or Mechanical Turk, to try to get a higher diversity range in our participants, for example. So if we think it's important, we do try to incorporate that. Yeah.
Yeah, but so, and what about, I guess, sort of, I was more thinking about, even if you, for example, have the same gender and you're from the same religion or whatever, but then you just, you've met different people in your life. So because of that, for example, my mum is very smiley, and therefore I trust people that smile.
Sure. Gotcha.
And whereas, I mean, I'm also very smiley, and I know that lots of people have a bit of trust issues with that. So it's like two different groups, and one group think it's like, oh, I can trust her, and the other group is like, no, not serious.
Okay.
So
no, that's not something we took into account. It's a very interesting point, though. Yeah, it's a good point.
Yeah,
sure. Those types of things could make a difference. I mean, generally the effects we're looking at for those things are quite small, all right. So I mean, that does imply that there's probably quite a range of people, you know. So we're looking for small effects in those cases. So it's the general population, I suppose. But yeah, whether or not it's conclusively everybody thinks that a smiley character is untrustworthy is, you know, is probably not as likely. Yeah, that's interesting though. Yeah.
Okay, thank you.
Thanks, Emily. Are there any other questions from? I'm just looking for hands. Someone in the chat. Oh no. I was just Polly saying that she trusts you, Emily. Right. Just so like earlier on when you were talking about shape and kind of material, I guess, like are you kind of texture maps like I guess materials generally covering texture maps, right?
Yeah.
So like one thing I find when let's say we're using 3D models, or let's say you take like a computer vision paper now, right? Which is going to say, I'm going to fit a morpho model to a photograph, and I'm going to try and estimate the 3D shape of someone's face from a photograph, right?
Yeah.
So you look at the shape, right, and it doesn't look very good, right? Still, I think state of the art still doesn't really capture the shape. Like it's so.
Yeah, it's
I don't think you could even give the photograph and give the model without the texture next to them and say, like, if you ask someone to match the shape to a different photograph identity, I think people would generally get it like.
Right, yeah.
The shape, the geometry is not really being well, but as soon as you put the texture on it, it looks awesome.
Yeah.
Right. So I think there's a strange like. I guess, but then if you start to light it really well, I think then, you know, the geometry comes back into it more powerful. But so when you're doing your experiments, like when you're looking for the effect of shape and the effect of texture, do you, I mean, maybe in your recent paper where you're looking at lighting, are you finding that lighting is like, you know, the more well lit or the more shadow you put in your scene, like, do you get a stronger effect of shape or something? Like, are you finding this coming out in your experiments in any way? This relation?
So things like shape from shading. Yeah, we looked at this quite closely in that experiment, but I don't know if there's anything to say that it made much of a difference. Yes, I suppose none of the measures that we tested would have brought that out as such. But I see what you mean. We certainly had an effect of that when we did an experiment. I didn't show it here, but on a 2D kind of a cartoon rendering. And the lighting effect on that, if the geometry was poor, was really ugly, you know. So especially when you've got like a very cartoony stylization. In fact, the less detail on the geometry, the better. That's casting the shadow of the light, because we're used to seeing very artist-generated shadows for cartoon characters, you know, and or with really nice smooth geometry. So that was definitely something where when we did like a 2D like ink and paint kind of effect, that the shadow was ugly if the geometry was too detailed. But other than that, no, I don't know if we've come across that. But yeah, a lot of the time, you know, it does take a lot of time to get the right lighting right, so that it looks good. You know, so you're not like casting a shadow of the nose down here, or you know. So I don't know in terms of the level of detail of the geometry and lighting, but I guess some of the more recent characters we have very high detail geometry anyway. So you know, we've just played around with the lighting on those. You know.
I guess yes. I guess it's
Interesting
like
point though.
I think, you know, maybe you can you can get away with like a bad shape if you've got a really good texture. I guess is like maybe you can make up the deficiencies in. So like,
Yeah.
do you need skin pore level detail in normal maps? Do you need like wrinkle level, like messes, like kind of you know, macroscope, like
I
what
get you, yeah.
details do you need? I think you get, like you can fake a lot of that with a good texture, I guess, is
Yeah,
where,
yeah.
where I'm kind of thinking, and that's kind of interesting then if you're trying to optimize or trying to like increase realism. Yes, this is kind of, I see it again and again in vision papers where like
Yeah.
people are trying to
We
extract.
did like just a final year project student of mine did an experiment recently where she looked at she generated 4 different levels of realism in Unreal of the same virtual character, and she did things like added displacement maps or added like ray traced shadows versus non-ray traced, and she looked at the effect on those things on realism. And yeah, like the improvement in the geometry with the displacement map did have a big effect, you know, on the realism level. But again, I suppose it depends on the base model as well, you know. So
Yeah,
there's so many parameters. Is the problem.
yeah, definitely.
Yeah.
Actually, so I see Vinay has put his hand up. So maybe Vinay, do you want to?
Yeah, thanks, Darren. Thanks, Rachel. Nice talk. So my question was more about the audio visual aspect.
Yeah.
And so one aspect which has been recently pointed out is that the audio plays a big role in the realism, perception of realism. And for instance, the team's audience mentioned that if the audio is not so good, then they get more affected by the experience rather than the video aspects as well. So so in these so you done the nice experiment with the smiling voice and the mismatched audio visual aspects, but how well would some amount of, for instance, synthetism in the audio, would that play also a big role? Can you talk about that?
Yeah.
Like for
Yeah.
instance,
So yeah, if you had like a text to speach voice, is it, or a kind of
exactly.
synthesized voice? Yeah. We've played around with that on 3 different experiments. So one of them, what were, I was trying to remember what our results were. So we were looking at the effect on realism. Yeah, the voice had an effect, all right, that time. So but I think it had more of an effect on the realistic character than it did on the cartoon, but I may be wrong. We did that whole VR experiment again with the synthesized voice as well, the empathetic one, because we felt that maybe, you know, the level of empathy or that would be affected by a synthesized voice. And actually we found no results in that, as we didn't publish that. But it made no difference if the character used a synthesized voice or not. So I guess that's kind of interesting. But in our more recent work, we're looking at the realism of things like gesture perception, and whether or not a synthesized voice affects that. You know, so like we're very, you know, we generate gestures that are based on our ideas in our head, and so our speech is also coming from our brain. And but we were interested in if synthesized speech and realistic gestures creates a mismatch, for example. So yeah, we have looked at synthesized speech quite a bit, but I guess it's another big parameter that needs to be investigated in a lot of detail, I would imagine, to try to determine exactly what the effects are. So we've done some small research. I was surprised, I have to say, that in that experiment, the realistic character, there was no effect on appeal or things like that. I mean, her realism went down, overall. She was rated less realistic with a synthesized voice, but it didn't affect things like how close you got to her or other ratings of empathy and that. So yeah, that we're aware of the question of audio, but it's not one that we've investigated in a lot of detail yet. But we definitely will be in the future.
Yeah, thanks.
Thanks.
Anyone want to ask maybe a final question? Like, if I could ask like one more then, just really quick, while I'm just like keeping everyone on the thing. Like, so I mean, generally in VR, right? So if I'm using VR, and if I'm interacting with the character in VR, like the experience can be a lot more powerful than if I'm looking at the same thing in 2D. I mean, do you see, like, are you adjusting for any effect of like the heightened response in VR or something, or do you think that I don't know, how do you find that is, are you finding that that's kind of having an influence on any like, are you like, you taking into account, or are you finding that it's like, maybe is it a bias in your results or something? Or I mean, we
ran the same experiment on a big screen and in VR to determine, and we found that realism in that case was more positive for VR than it was for on screen. So in that case, people had, they preferred realism in virtual reality than in the screen. But other than that, there was no effect in that particular experiment. But personally, like the last experiment there with the female character, I found myself in VR standing next to her. I found it super creepy because I actually found I don't know, she doesn't look as realistic maybe in the videos, but when you stand right beside her and you look at her face, it's very it's kind of unnerving almost, so I definitely think there's heightened sensation for sure in virtual reality, definitely, because you're right there in the room with this person, and I mean, I suppose it speaks to the illusion that you have in virtual reality, the fact that people always walk up to the characters, but they never walk through them. They could easily walk through them if they wanted, but I mean, I actually tried myself. I said I make myself walk through her, and I couldn't do it. Like it just felt weird. So no, there's no doubt that in virtual reality it's going to. But I mean, there's not very many people investigating photorealism in virtual reality at the moment. So there's been a lot of research, as you know, over the years and years on all these different effects in virtual reality. But I personally feel that, like, having this photorealism that we're getting now and like real-time ray tracing, all that is going to have a massive impact in virtual reality. And I don't think people are quite ready for it or haven't really studied it very, very much. So yeah, I think the sensation is definitely heightened in VR for sure.
I mean, definitely threat. I definitely feel like there's more of a threat response. Like, there's definitely more of a, like, the threat of a physical thing, even though it's not physical. I think that I find with characters definitely not. I mean, like, I'd be interested. I wonder whether, like, like, I'm sure that, like, people have done quite a lot of research in this area, which is not public. Because I guess if I was working for an army research center, maybe I'd be kind of
True.
things. Cool. So okay. So I think maybe we should wrap up then. It's been really great. I don't want to take up any more people's time today. So thank everyone virtually again for Rachel coming and giving the talk. It was great to have you. Really nice to hear about your work. Good luck with the SIGGRAPH presentation. And yeah, look forward to kind of seeing more of your stuff. And I guess I'll see you on Thursday for Emma's Viva.
Yeah. Thanks for that. Okay, thanks for having me and for listening.
All right.
Bye. Bye-bye.
Thanks.